Okay, so let's talk about 21.4 on page 551. Theorems and corollaries. Now let me be clear. You are never going to have to write the definition for a theorem or a corollary. That's not part of this class. That's not what this is about. This class deals with using formulas and using equations to help solve problems. It doesn't have anything to do with, there's very little theory in this class, although sometimes I will point it out. But you will not have to identify those things. So you're not going to be memorizing any kind of definitions in that way. Now, understanding what they are sometimes helps, but as far as you like memorizing something for a quiz or for a test, like in that manner, no. So, with that out of the way, what is a theorem? A theorem is something that can be proven. Ooh, shadow puppets. Anyway, so, and a corollary is part of, or based on a theorem. Okay, that's out of the way. Now let's look at the first one. It says if two lines intersect, the opposite or vertical angles are equal. So whenever you have two lines that come together, at that point right there, then that means that this angle and this angle are going to be, we can call them either vertical or opposite. Vertical angles or opposite angles. They are going to be the same. This angle and this angle are also vertical angles as well. So these two angles are the same. Okay, that's the first one. And the second one and the next one go together. Now we're going to start talking about parallel lines. If two parallel lines are intersected by a transversal, so let me get two parallel lines. We're going to make the assumption that this line and this line are parallel. It's not bad. I don't always write the arrows on my lines. I should. And we've got a transversal coming through here. Okay, if two lines are intersected by a transversal, then that means that the alternate interior angles are equal. So that means that not only, I've mentioned it before about alternate interior angles, but now because these two lines are parallel, by definition, that means that this angle and this angle are the same. Alternate interior angles are equal. And also, these are the same here as well, because these are alternate interior angles. Okay? So, because these two lines are parallel, then this angle and this angle are the same. And also, this one and this one are the same. Okay? So that one goes along with the next one on page 552, which says, if two lines are intersected by a transversal, and a pair of internal angles, alternate interior angles, are equal, then that means that the lines are parallel. So it's sort of the same thing, but saying it a different way. So right now I have two lines. I don't know if they're parallel or not yet. So I have two lines intersected by a transversal, and if the alternate interior angles are equal, then therefore the lines are parallel. So it's just the same one, just sort of said a different way. So the first one says that if two lines are parallel, then therefore alternate interior angles are equal. The second one says that if you've got alternate interior angles that are equal, that means that the lines are parallel. So it's the same thing, just said the other way. Now, the next two go together as well. It says if two parallel lines, let me draw two more parallel lines here. Perfect. Well, maybe not, but close enough. Okay, if two parallel lines are intersected by a transversal, corresponding angles are equal. So that means that there are several sets of corresponding angles. I'm just going to use this one right here, and also this one right here. So these two are corresponding angles, and these two are. So if two parallel lines, I'm given that these two lines are parallel now. If this is the case, and then there's a transversal that comes through, then that means that corresponding angles are equal. These aren't the only two sets of corresponding angles, and I don't want to get it all messy in there. Okay? Now, the next one says that if two lines are intersected by a transversal, so at the moment I don't know that these two lines are parallel, but if two lines are intersected by a transversal and a pair of corresponding angles are equal, so this angle and this angle are equal, then that is given that the two lines are going to be parallel. So it's the same thing, just kind of said the other way. So if corresponding angles are equal, then that proves to me that the lines are parallel. And if the line, going back to the other one, if the lines are parallel, then that proves to me that the corresponding angles are equal. So as you can see, they're the same one, but it's just worded differently. One is proving the other, and then vice versa on the other way. Okay, so the next one, two angles are either equal or supplementary if their corresponding sides are parallel. So let's draw this situation. What are we talking about here? I want to kind of draw it like this. So I've got that line there, and then I'm going to come over here and that line there. I'm going to try, these two lines right here are parallel. Okay? And then I'll draw this angle here and this one here. Okay? So these lines here are parallel, and these lines here are parallel as well. If this is the case, so two angles are either equal or supplementary if their corresponding sides are parallel. Okay, so this side and this side are parallel, this side and this side are parallel. That tells me that the angles are either equal or supplementary. So this angle and this angle are equal to each other. This angle is supplementary to that angle because this is a straight line. A straight line is 180. And if this angle and this angle add up to be 180, and this angle is equal to that one, therefore, we go back to some of the other postulates that we learned before. If this angle and this angle add up to be 180, then that means that this angle and this angle add up to be 180. So, these two sides are parallel, and these two are parallel. So therefore, the angles that are represented by those sides are either equal or supplementary. Okay, so what's the next one say? Dun, 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 dun. Two angles are either equal or supplementary if their corresponding sides are perpendicular. This one I'm just going to show you because I'm not drawing that one out. Oop, the other way, right here. Yeah, right there. All right, so they got a lot of lines on here. So this is one angle right here, angle 1. And we have a line here, and we've got angle 2 here and angle 3 right there. Okay? Now, I'll restate it. Two angles are equal or supplementary if their corresponding sides are perpendicular. So if we move this side out along with this side, there's a 90-degree angle right there. So 90 degrees means it's perpendicular. If I come with this angle right to here, and that makes a 90-degree angle. So if that's the case, then that means that this angle and this angle are equal, and this angle right here, angle 3, those two angles are supplementary. The same way we had supplementary angles before. Now that one might seem a bit tricky, so kind of look at that one for a while, stare at it, and hit yourself in the head with it and all kinds of stuff if it helps. You know, bang your head on it. Maybe Quiet Riot had a point with the Bang Your Head song. 80s rock. Quiet Riot, what a name for a band. All right, so let's take a look at page 554, and we're going to look at that example right there. Maybe I should have had that one under. All right, so we have, I'll put it right here, I got more room. A line here, a line here, a transversal coming here, a transversal here, and another one right there. And so AB, CD, let's see, GH, EF. I should have this stuff prepared beforehand. Oh well. I wing it. Okay, so we've got this figure right here. Now, just below that it says given that AB is parallel to CD. So that means that this line is parallel to that line. And EF and GH are parallel. So that means that this line is parallel to that line. And then they give angle 1 is 115, so I'll write angle 1 is 115 right there. And angle 2 is 82. So over here we have 82. All right, determine the other angles. All right, so this is a situation where what I need to do is I need to focus on just one set of lines at a time. So for example, I'm just going to focus on those two parallel lines right there with that transversal for the moment. And then I'll focus on these in a minute. But first I'm just going to focus here. So try to ignore that stuff for a moment. So if this angle is 115, now I know from what we just mentioned that opposite angles are the same. So therefore, this line and this line come together, so opposite angles are the same. So that is 115 right there. All right. Now, we also know there's a couple of different ways we can approach this. Because this line and this line are parallel, alternate interior angles are the same. Also, corresponding angles are the same. So that makes this angle 115 as well. And this one is 115. Come on. 115 as well because they're opposite angles right there. Now, what's the other angle here? Whenever you have two parallel lines intersected by a transversal, now I'm not talking about this part, I'm just talking about this part right here. You're only going to have two angular measures. So we've already got all the 115s. Now the other one will be supplementary to the 115 because I've got a straight, well, it should be a straight line. That's 180. So we take 180, subtract 15, and we get 65. So that one's 65. So therefore, now I can go lots of different ways with this. I can say corresponding angles are equal because these are parallel lines. So that one is 65. That's an opposite angle right there. So, and it's also an alternate interior angle, so you can look at it either way. So I've got 65 there. And this is a corresponding angle and an opposite angle. So 65. So all of those, we have two measurements for the angles. Unless, now if this transversal was perpendicular, then they would all be 90, but that's not the case here. All right, so let's approach this one now. Okay, so now let's just focus on this part. These two lines are parallel, so there's a couple ways you can visualize this. I can visualize it by dragging this line over to meet up with that line if you wanted to. That would make that one transversal coming down through. So we would have the same kind of situation as we did over here. Two sets of angles. You don't have to do it that way. You could just understand, because of the postulate or the theorem we just mentioned, the middle one on page 553, it says two angles are either equal or supplementary if their corresponding sides are parallel. That's the one I think that's the one they want you to focus on for this. But like I said, you can visualize it as, because these two lines are parallel, I can just simply move this over until it matches and makes one line. But this line is parallel to that one, and this line is parallel to that one. That makes this one 82 as well. Now we can just do opposite. We can do opposite. So this one has to be 82. This one's opposite, so that's 82. So now we can do complementary angles. So this one must be 98 because these two add up to be 180. So therefore, now this one's 98 and 98 and 98. All right. So that's all of the angles found in this system right here. And we used some of those theorems. Well, we used all of the theorems, mostly anyway.